All right. Good morning, everybody. Happy May 1st. Happy Friday. Hope everybody's doing well. We're going to go ahead and we're going to keep talking about circles. We're going to go ahead and talk about arcs and sectors today. So we're going to go ahead and look at arc length, sector, area. There's some pretty easy formulas to work with, some basic definitions. I gave you guys a really short assignment on Pearson that I'll show you right at the end here. It's 6 questions long. So I appreciate everybody that's sticking with me and everything like that. We're going to go ahead and jump right in so I can try to keep this as short as possible here today. So we started looking at circles last week, and we started looking at circles in the coordinate plane. While we were doing that, we were looking at the equations and we were talking about graphing circles. Now we're going to look at circles in more of a geometric perspective. So we're not thinking about them in a coordinate plane anymore. We're just kind of thinking about their properties and everything like that. So I actually just wanted to first start off by defining circle is a point called the center. And the set of all points equidistant from that point. We'll talk about what equidistant means in just a second. Pretty self-explanatory, actually. So it's a point called the center and the set of all points that are equal distances from that point. So when I say equidistant, it means that every point has to be equal distances. That distance is called the radius. So when you guys go through and we draw a circle, you guys will see it starts here with the center. And then as I pull that circle, every point is going to be the exact same distance away from that center. So when we draw circles like this, we always try to put a point in the middle and label that. So I'm just going to go ahead and call it P. So, and you guys will notice they'll call this circle P. The distance from the center to the outside. So I'm going to go ahead and let's label this point Q. So PQ, the distance from the center to the outside, is called the radius. And that distance is going to be the same from the center to any point on the circle. If I was to draw another line that went through that center, and I've got P and Q, let's go ahead and put R and S. That segment RS is called the diameter. So we've got the radius and the diameter. Two things that we're going to look at with this, actually 3 things. We're going to find the length of portions of the outside of the circle. We're going to find the area of segments of part of the inside, and we're going to look at how we can find those. So first definition and the first thing that we're actually going to go through and we're going to find is called arc measure. We'll define what an arc is in just a second here. So arc measure. An arc is an unbroken portion of the outside of a circle. So if I was looking at the circle that I have up here above, if I was wanting to talk about an arc might be this length from here to here. We're going to look at the measure of those arcs in degrees, and then later we're going to try to find their length in actual units, and that's going to be the difference between arc measure and arc length. Arc measure is usually the first thing that we look at. Arc measure is pretty easy as long as we have a central angle. So in order to go through and to find arc measure, I'm going to go ahead and I'm going to draw another circle down here. Let's see if we can change that to black. There we go. Oh, that's more of an oval. Let's undo that. Hold on. I want a circle, not an oval. Ooh. Sorry, guys. So that one looks like a circle to me. Let's go ahead and again put a point in the center. And this time we'll go ahead and we'll call it C, so it's really easy to tell. C is for center of that circle. We're going to go ahead and we're going to put some points on the outside here. So let's go ahead and put a point there. And then I want to go ahead and have that line go right through the center and connect with a point on the other side. And then let's do the same thing over here. So draw another point, and then we're gonna have it go right through the center to the outside there. And we're gonna go ahead and label this. Let's go ahead and go with PQRS. Now arcs, again, when we're talking about arcs, what we're talking about is we're talking about a portion of the outside of the circle. If we're talking about the entire outside of the circle, we're talking about circumference. Right now, we're just talking about a portion of it, and it's an arc, okay? Right now, when we're trying to find it, we're trying to find the arc measure. Arc measure is in degrees. So we're not interested in the length yet. Right now, we're looking at it in degrees. What's really, really nice about arc measure is the measure of an arc is equal to the measure of its central angle. When we talk about a central angle, we're talking about an angle that's formed at the center of the circle. So if I wanted to go through and I wanted to talk about, hey, I wanted to find the measure of the arc PQ. I want to know, hey, how many degrees is it from right here to right here? What portion of a circle is it, basically, is what I'm looking at. The measure of the arc PQ is going to be the exact same as the measure of its central angle. So the measure of that arc PQ is going to be the same as the measure of this angle. Those are going to be the same, so that's equal to the measure of the angle PCQ. The measure of an arc is equal to the measure of its central angle. So we can go through, and we know how to find the measure of angles. Sometimes they'll go through and they'll give them to us. We could say the same thing is true. If I wanted to go through and say, hey, what's the measure of this arc RQ? Well, I know it's going to be the measure of RCQ. I also know that it's going to be the same, sorry guys, as that arc over there, that arc PS. I know that because those are vertical angles, right? So we can go through and we can do things like this. In order to find the measure of an arc, and when they say arc measure, they want degrees. When they're talking about arc length in a second, we're going to be going through, we're going to find that as an overall length, okay? So to find the measure of an arc, we find the measure of its central. We'll go ahead and we'll show you guys what we're talking about. These are fairly easy. You'll run into a few of these in homework. We can do a meeting on Monday to go through and do a few more examples. So I'm going to go ahead and draw my circle, and we'll see how bad that is. That wasn't too bad. I'm going to go ahead and put a point in the center. That was really bad. Point in the center was worse than the circle. Put a point in the center, M. I'm going to draw a line through it that way. And we're going to label that B and that one D. I'm going to draw a line through this way. And I'm going to have A and I'm going to have C. And then I'm going to draw a line straight down in E. Go ahead and draw that for me. The reason I didn't have them drawn ahead of time was because I wanted you guys to be able to see where I was putting the lines. A lot of the time, if you guys are going through and you guys are doing those, your drawings can end up being really, really bad. We're also going to label that point M in the middle. So actually, you know what? I'm not going to label the center, but it was point M. You know what? Actually, I need to. So I used M for middle, but so they're going to ask us, they're going to say, hey, we need you to find a few things. And this is like the problems that you'll have to do in the homework. We're going to find the measure of the arc AB. We're also going to go through and we're going to find the measure of the angle CMB. So we're going to find those two things. I want to find the arc AB and I want to find the measure of the angle CMB. So what I'm going to have you guys do when we're going through and we're doing problems like this is we're going to go through and we're going to see if we can find the measure of all the angles. If we can find the measure of all the angles on the inside, then we can find the measure of all the arcs. We're not always going to be able to find the measure of all the angles, but a lot of the time they'll give us enough information too. We can use things that we already know. So we can use things like right angles are 90 degrees. We can use things like straight lines are 180 degrees. We can use things like vertical angles are congruent. So we're going to go through and we're going to use ideas like that, and we're going to see what happens here. So I went through and I looked at this circle. Don't even worry about what you're trying to find yet. We'll find that in a second, okay? I want to go through and I want to see if I can find the measure of all the angles. I know this box there means that's 90. So I know I've got a 90-degree angle there. The other thing that I'm looking at when I see this is I see that this is a straight line right there. So I know since that is a straight line, I'm going to undo that. But the diameter is straight. I know that has to be 180 degrees. This straight line right here, these two angles, you guys can't see it, but that angle and that angle there, those make up a straight line. Those are a linear pair. So I know they have to equal 180. So if I wanted to find this one over here, I could go, hey, what's 180 minus 130? That's 50 degrees. So I know I got 50 there. Well, I also know, and I'm going to highlight again and then I'll erase it. I also know that this is a straight line right there. So since that's a straight line, I know those angles have to add up to 180. Well, I've got 90 right here, and I've got the 50 I just found. So those two are 180, or 140, I'm sorry. If we go through and do 180 minus 140, you guys get the 40 degrees that's left there. And then we know that this is also a straight line, BD. So I can go 90 and 40 is 130. And go, hey, 180 minus 130 is 50 degrees. If you guys were here, you guys would have said, hey, Mr. Bickle, we could have done that anyways because I know that these are vertical. The other thing you guys can remember is that a circle is 360. So all the angles inside of a circle have to add up to 360 degrees, so you can add them all and subtract from there. You guys have done all the work now. Once you know what all those are, we know what all these arcs are. This is 130. This is 50. This is 40. That's 90. That's 50. See what they asked you to find. AB. AB goes here. That's 50 degrees. CMB. C to M to B is right here. That central angle is 130 degrees. Did I give you that one to start? Yeah, I think I originally meant to put CMD. So measure CMD would have been 50. But you guys can go through. Sometimes they could go through and say, hey, what's the measure of the arc? And they might say, hey, ADC. If they put 3 points in there, just remember you have to go through this point in the middle to get to the end. So I'm looking for ADC. I start at A, and I go around, make sure I hit D, and then get to C. So that right there is half of a circle, so we know that would have to be 180 degrees. You couldn't go the other way because you would run into C first. All right, so that's going through and finding the measure of central angles. I'm not going to do another one of those with you guys because I think you guys are totally capable of those. Right angles are 90, straight lines are 180. Look for vertical angles. Remember, all the angles inside the circle have to add up to 360, and you guys can go through and you guys can find those. 2 more things that we're going to do. They're going to be pretty much formulas if we come down to it. This is arc measure. When I'm going through and I'm finding the arc measure, I'm looking for degrees. The next thing we're going to be looking at is we're going to be looking at arc length. Now, arc length and sector area, the next 2 things we're looking at, they're both the same idea. They're just proportional relationships. Arc length is a portion of the outside of a circle. We're talking about arc length, we're still talking about that same idea. We're still talking about an unbroken portion on the outside. So let's go ahead and draw another circle there. That one wasn't bad either. We're still going to have a point in the center, which is C. But now they're going to give us something like this. And I'm going to go ahead and put A there and B there. They're always going to go through and they're going to give us this radius. And we're going to have a way, hopefully you guys can't hear my daughter crying. They're going to have a way to find this angle on the inside here. And we'll be able to go through and we'll be able to find the length of this segment AB. Now what's nice for us, and I know you guys all remember, did I define it up here? No, we didn't talk about it. But you guys know that if you were to find the distance around this entire circle, that's called circumference. The circumference of a circle is if you went through and kind of thought about laying a string over the circle. If you took that string and you unrolled it and you laid it out, that length would be circumference. There are 2 ways to find the circumference of a circle. One formula is 2 times pi times the radius. The other one is pi times the diameter. The reason those two are the same is because 2 times the radius is equal to the diameter. So that's nice. So I know if I wanted to find the whole distance around the outside of the circle, it's 2 pi r, or it's pi times the diameter. But I don't want the whole distance around the outside of the circle. I just want this portion from A to B. Now, the way I drew this almost looks like it's a 90-degree angle. So most of you guys are pretty smart. You'd be able to figure out that this is a quarter of the circle, right? So I just want a quarter of the circumference. The way we're going to find that and the way we're going to go through the formula that we're going to use is the length of an arc is equal to, it's going to be the measure in degrees over 360, and we'll talk about that in a second, times, and I'm going to write 2 pi r for the circumference. You can also use pi times d. This measure in degrees over 360, guys, this is just the portion of the circle that we want. So if that was a 90-degree angle in our example, we would want 1/4 because it's 1/4 of the circle. 90 over 360 is 1/4. So we'll go through, we'll reduce some fractions, and we'll go from there. So this formula you guys will need anytime they ask for arc length, okay? So anytime they ask for arc length, you guys are going to use that formula. Let me show you how to use it. And when you guys go through and do these problems, it's really easy because we keep our answers in terms of pi. So I'm going to draw this circle. That's a really bad one. Pretend it's a circle for me. Let's put A there, and we're going to put D there. This is 140 degrees. This is 4 centimeters. And they want us to find the length of AD. So if you guys think you know how to go about it and you guys can work on it yourselves, go ahead. We're going to do one more after this. So if you guys need to watch me do this one, you guys can watch this one and then try the next one. So we're trying to find the length of AD. I want to go through and find this length on the outside there. Again, they asked me for the length, not the measure. That's how I know it's arc length. So we need to go through, we need to find what the measure in degrees is. So what's the measure of our angle? What's the portion of our circle we're looking at? And then pretty much go through and find the circumference. They told us here that this angle is 140 degrees. So again, this 140 over 360, guys, that's the portion of the circle. That's the portion of the circumference that we're actually looking at. So I've got 140 over 360 there. And then I'm going to multiply that times 2 times pi times my radius, which is 4. Sorry, I keep getting my hands all over the screen. Let's go ahead and reduce this fraction if we can. Now, I know a lot of you guys are going to want to dump this into a calculator and give a decimal. We like exact answers, so we leave pi in there, okay? So that when you guys go through and simplify this, this is how we're going to do this. We're going to reduce this fraction. So 140 over 360, we can go through and cross off the zeros, divide both of them by 10. Now I've got 14 over 36. Those are both even. So I can divide a 2 out, and that leaves me with 7 over 18. 14 divided by 2 is 7. 36 divided by 2 is 18. And then that's times 2 times pi times 4. That's 8 pi. We're going to leave that pi in our answer, guys. Pi is fine. So now we're going to multiply. 7 times 8, 35, 42, 49, 56. So that's 56 over 18 times pi. And then we're going to be able to reduce the fraction from there. Both of those are even again. So that makes 28 over 9 times pi. And that would be centimeters. Now that is an exact answer. I know you guys look at that and you're going 28 over 9 pi centimeters. That makes no sense at all. 28 over 9 is just over 3. So, I mean, that's 3 1/9. So that's 3.1. Pi is 3.14. So it's 3.1 times 3.14. It's a number somewhere around 10. As mathematicians, we like to have the exact answer with pi because if we continue to do any calculations with it later, then it's going to go through and make that easier for us. And our calculations are going to be closer to exact. So again, portion, measuring of your angle over 360 times the circumference, okay? Let's do another one. I'll try to go quicker. There's a little bit more on this. I'm trying to keep these videos as short as possible, guys, but make sure that you still have some examples to work through. On Monday, we will have a meeting and we can go through and do any problems. ones. I'll post a warm-up thing for you guys too, so we can go through and do 3 or 4 of those. Let's go ahead. I'm going to redraw that. Let's pretend that line's straight. Pretend my thing's a circle again. So let's put X there, W there. And we're going to come out here, come out here. Diagrams are not drawn to scale. So there's Y and Z. They're going to tell us that the measure of the arc WXY is 195 degrees. They're going to tell you the measure of the arc WZ is 61 degrees. They're also going to tell you the diameter is 22. They want you to find the length of YZ. So if you guys are going to go through and try this on your own before you guys start, they gave you some information here. Use that inside your circle and things we did before to find the measure of all those angles. And then see if you guys can use that to find what that angle is supposed to be for Y. And if I had labeled that, that'd be YCZ. Okay. So go ahead and pause, see if you guys can figure that out, and then come back and I'll work through it. All right, so I'm going to go ahead and I'm going to fill in these values inside. They told me WXY was 195. So if I start here at W and I go all the way around to X and I go all the way around there to Y, that's 195. So I'm going to go ahead and just go like this, go 195 degrees. Now I know that that looks like it's more than 15, stuff's not drawn to scale. They told me, and I'm going to go ahead, colors. WZ is 61. So WZ right there, that's 61 degrees. Okay. So I know that this entire circle has to be 360. So if I go through and I add those two, the 191 and the 61, I get 252, which means this has to be 108 degrees, right? That's what's left. Again, I know that does not look like 108 degrees. We're going to pretend it is, okay? So I was able to go through and able to find the measure of this central angle YCZ to be 108 degrees. I was able to find that because I know that the measure of the central angle is the same as the measure of the arc. So I was able to use what we did before to go through and to find that. Now, and I'm going to erase that 108 on the outside because it looks confusing, they told me the diameter was 22. So that means this diameter, this distance the whole way across there is 22. So if I want to find the arc length, I want the measure in degrees, 108 over 360 times the circumference, which is 2 pi r or pi times the diameter. So pi times 22. This fraction's a little more confusing to go through and reduce. That's 54 over 180, which is 27 over 90. Which is 3 over 10. And then that's times 22 pi. We will able to multiply there. And 22 times 3 is 66 over 10 pi. Divide those out, I get 33 over 5 pi. Which is not what I got when I did it earlier. So I'm wondering if there's a mistake in there somewhere. I'm looking really quick, guys. 256. Haha, this is supposed to be 195. The measure of the central angle is wrong. So, okay. You guys just went through and watched me did the whole thing, and I did it wrong. And I put 191 there instead of 195. So if I would have used 195 plus 61, that's 256, which gives me 104 there. So this should have been 104 over 360. And failure. That was 104 over 360, which makes that 52 over 180, which makes that 26 over 90. Sorry. Which makes that 13 over 45. 13 times 22, 220 plus 66. Oh, geez, 286 over 45. That's what I got when I did it earlier. So, answer doesn't look pretty. 286 over 45, that's a little little bit over 6, and then times pi, which is 3.14. So it's 6.2 times 3.1. You're up at like 20 something. In order to find arc length, you guys want the measure in degrees of whatever the arc is over 360 times your circumference. So times either 2 pi times the radius or pi times the diameter. If they don't give you the measure of your angles, go through and use information given to go through and define those. Now that we've done this, I'm hoping this next part is really easy. The last part here, I think I'm cruising today getting through this. Last one is called sector area. The reason sector area becomes so easy now is because sector area is just going to be the area of a portion of a circle, okay? So when we talk about a sector is just a portion on the inside. Again, let's keep that circle centered at C. Let's put this point A and this point B. Now, if we draw those going out, if I go through and I color this part in, this is a sector. So in this section, guys, everything we're really looking at, it's all proportional. If you think about it, similarity with proportion, trait proportional. We're looking at proportional relationships in circles now. So this is sector ACB. To find the area of sector ACB, we're just looking at a portion of the area of the whole circle. So if this is my radius R, I know all I have to do is I need to take what the normal area would be, which is pi r squared, and I need to divide that by whatever portion of the circle I'm looking at.
So if I look at the measure of my angle again in degrees over 360, the only thing that changes between sector area and arc length is instead of using the formula for circumference, we're using the formula for area. So when they're asking you to find something on the inside, we're using pi r
squared instead of 2 pi r. Okay. Again, let's go through this fairly quickly. We'll do some more problems with it next week. I wanted to introduce it and let you guys kind of see it. That was a horrible circle. So let's go ahead and put the center C there. Let's go ahead. I'm going to draw it like that. So let's make that 125 degrees. Oh, geez, I'm changing numbers. You guys know this is a bad idea because now I don't have my answers. So I'm going to make that 130 degrees. It looks like it's about 130. I'm also going to make this radius 10 feet. And let's call that M and B. So let's find the area of sector MCB. So what we're looking at, guys, we're looking to find the area inside the circle right here, okay? So I want to know what's the portion of just that area on the inside, okay? So if we found the area of the whole circle, I just need to go through and go, what portion of it am I looking at? Well, I'm looking at 130 over 360 of it. There's 360 total degrees in the circle. All these interior angles on the inside here add up to 360. My central angle in this part is 130. So 130 over 360 times the area. The area is pi times your radius squared. That if we reduce again, the fact that we can divide tens out makes that nice. And 13 over 36 actually doesn't reduce at all. 10 squared is 10 times 10, so that's times 100 pi. 100 times 13, it's 1300 over 36 pi. And now let's start reducing. Those are both even. So I can call that 650 over 8. That's the 0. Sorry, guys. 650 over 18 pi. Let's call that 325 over 9 pi. And that is good. Let's go any farther than that. Now that number is a lot bigger than the last one was. That's because we're looking at area inside, so that's going to be bigger. Area is always, well, not always, but area is usually bigger than circumference. So when they ask you guys to go through and find sector area, it's the exact same idea. It's just the measure in degrees of your angle, your central angle, over 360 times use the area formula. So really quick to go over everything again. And one more time, we're going to go over this again on Monday. I'll do a little warm-up video. We'll do 3 or 4 problems, and then we'll have a conference afterwards if you guys want to talk about it. Arc measure, when they ask you to find it in degrees, these will be your first 2 problems. Your homework problem's really short. Go through, find the measure of the central angle. The measure of the central angle is the measure of the arc. Okay. That's when they ask for arc measure. Arc measures in degrees. When they ask you guys for arc length, now they're looking for the portion of the circle. So they want you guys to go through, find the measure of your central angle or the measure of that arc in degrees. That goes over 360 times the circumference formula, which is 2 pi r, or pi times the diameter. When they ask you guys for sector area, it's the measure of your angle in degrees over 360 times the area formula, which is pi r squared. Your guys' homework is on Pearson Realize. I keep getting messages from you guys saying, hey, sorry, I haven't been participating. I'm trying to do this. Sorry, I'm trying to do that. This stuff is stuff you guys are going to need to know in the future. It's going to come up and those kind of things. I don't know whether the teachers are planning on reviewing it or not, but when it comes up, it would be great if you guys already know it. So if you guys can just go with me, I did not give you guys that many problems. If I go through and just look at fourth is a very small class. Looks like I'm losing you guys though. I only got 1, 2. Well, I got 5 people that did that. If we go through, it is, I just put it on here, 10-1. So if you guys go through and you guys look at assignment 10-1, there are 6 problems on it. So let me see if I can preview. Sorry, I want to go through and just show you guys that it's really short and really easy. Yeah, question 1 of 6. So 2 of each kind of problems. First one, find the measure of the arc dB. So they're asking you to find the measure of this arc over here. They told you you've got a 120 and you've got a 90. It looks like we've got some straight lines and stuff, so you guys can go through and do that. Next one, same idea. Third one, they're asking you to find the measure of that arc right there. So they gave you the radius is 15, the arc is 30 degrees. Plug that into your arc length formula. Same idea on the next one. The last 2 are going to be the sector area problems. So they gave you really easy circles, guys, gave you the radius, and they gave you the sector of, or the measure of the arc. So go through, do those 6 problems. I'm trying to make this easy on you guys, not trying to do anything extra. So I miss everyone. I can't wait to see you guys next year, hopefully, and all that kind of stuff. 3-4 weeks left. It's going to be like 4 or 5 more sections. Okay. So stick with me. And I will hope you guys enjoy your weekend, and I will talk to you later. Okay.